Here is an important test question based on optimization, where we'll find the area using trigonometric functions, area for triangles and sectors. I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this video, we'll consider a very important question which is based on optimization. We're going to use trigonometric functions to solve the problem. It relates to a bird nest. The question here is, a bird nest is designed from a trunk of a tree in the shape given in the diagram. Diameter of the cylindrical trunk is 20 centimeters and 3 of its sides are chipped off. Find angle theta to maximize the area of the utilized wood. So that's the cross section of the trunk with diameter of 20 centimeters. That means that the radius here is 10, right? We need to find the angle theta to maximize the area of the green portion shown to us. Now in this green section, what we can do is we can extend this particular side and divide the area into 4 portions, one of them being a sector and then 3 triangles, correct? And finding the area of all the 3, combining them, gives us the formula for area. To maximize, we'll find the first derivative and analyze it. So that is going to be the strategy, correct? So the steps involved are, first, area of sector. So let's label them for better communication. Let's say A, B, C and D, right? O being the center. So we're talking about area of sector. Let me give you the formula here. Formula for area of sector is, as you know, half r square theta, right? Which you can derive, pi r square is the area of the circle times theta divided by 2 pi, right? So on the side, the formula is derived area is pi r square times the angle theta divided by total angle is 2 pi, right? So you cancel pi and you get half r square theta. That's the formula for area of sector. Now what is the formula for area of triangle? Especially when you're given 2 sides and included angle. So if 2 sides and included angle are given to us, let us say we have the sides as A and B. In this case, both are same and the angle is theta. Then it is half of A times B times sine of theta, right? That is the area of the triangle, right? So now, if you look into this, we can say that this area is half AB, A and B both are radius in this case, right? Now let's look into the other triangle. As you can see, the other angles here are what? This angle is 180 minus theta, or you can say pi minus theta, right? Either way. So in that case, you also realize that area of a triangle could be written as half A times B times sine theta in general. But if the theta is 180 minus pi, then you also know that sine of 180 minus theta is also sine theta, right? Is also sine theta. So effectively, area of all the 3 triangles is same, right? Because A is equal to B is equals to R, correct? So here, we have three different triangles, but their areas are exactly same. So we can say that area of three triangles is, let me write down here, three times half of r square sine theta. Make sense? Correct? So that becomes the area of three triangles, right? So we can actually add these two areas and get our expression. Perfect? So let's continue. So we get the expression for area of
after attending university. The winner of this year's Certificate of Achievement Schulich Leader Award is Akshi Kandivani.
Great. Our student, Akshit, gets highest marks and the most prestigious Schulich Leader Award. You can be there. Join our classes and excel.
the wood, which is sector area, plus 3 triangle area. So in this case, area function A can be written as the sector area being half r square theta plus 3 times area of the triangles, which is half of r square sine theta. So let's simplify this formula. We can take half r square common, and that leaves us with 3 theta plus 3 sine theta, right? So that becomes the formula. Now in our case, we know that r is equal to 10, and therefore area is half of 10 square times theta plus 3 sine theta, which 10 square is 100, right? Or we can simplify and write this as 50 times theta plus 3 sine theta, correct? So that becomes the expression for area. Now we need to maximize area, right? So to maximize, we'll find the derivative of this particular function and check for its maximum value, correct? So let's move on to a fresh page. We have our expression. Let me write down clearly. Area as a function of theta is equal to 50 times theta plus 3 sine theta. Clear? Okay. Now let's maximize. So we have area as equal to 50 times theta plus 3 sine theta. So now derivative of this area with respect to the angle theta is 50 times derivative of theta is 1, and for sine theta is cos theta. So we get 3 cos theta. So that becomes the derivative of this particular function. And in this particular case, for that to find a critical number, we have to equate this to 0. One plus 3 cos theta, correct? So let's solve for the factor 1 plus 3 cos theta and see when can we maximize the area. That means 1 plus 3 cos theta equals to 0, or 3 cos theta equals to minus 1, cos theta equals to minus 1 over 3. So theta is equals to cos inverse of 1 over minus 1 over 3. Or you can say, yeah, we'll get an angle in quadrant 2, right? So let's use calculator and find this particular angle. So in radians, we have shift cos inverse minus 1 divided by 3. So if you do minus 1 divided by 3, you will get the negative angle, right? But well, the calculator did give me minus 1.9. That's good. So theta equals to 1.910. Correct? So as you know, this is an obtuse angle, correct? Because you know the cos rule. And pi by 2 is basically equal to 1.57. So 1.91 means that you are in quadrant 2. So that gives you the angle 1.91 in radians. Is that clear to you? Now we need to check whether this is indeed giving a maximum or not. Right? So let's analyze the first derivative. By taking a value of theta less than this and more than this, correct? As you can also see in the diagram, the theta has to be less than 180, right? Is that clear? So let's analyze this. Our critical number is 1.91. Taking a value on the right side, we can take 1, and on the left side, we can take 1 on the left side, and on the right, let's take a value of 2. So when I substitute this in the expression, which is 1 plus 3 cos theta, then what do I get? Substituting 1 gives me a positive value, since this is an acute angle, right? It is an acute angle. So that gives me a positive value. And substituting 2, cosine is negative and 3 times that is more than 1. So that gives me a negative value. And therefore, we confirm that at 1.91, we have a maximum area. You get the idea. So we have a maximum area by analyzing the critical point. Correct? So find the angle theta to maximize this. So in radians, the angle theta is 1.91, right? Well, let us convert that to degrees, right? So you can write this. Let's do it on the next page. We got the angle theta, maximum area. Theta is 1.91 radians. Correct? You would also find this angle in degrees, correct? Or you can convert it now. So 1.91 times 180 divided by pi, right? Gives you 109.4 degrees. Or in previous case, you could have, if the angle required is in degrees, right? Sometimes they do want it, right? You could also find shift. You change your mode to degrees first. And then you can do shift cos inverse of minus 1 divided by 3. So you get 109.47, which can be rounded to 109.5 degrees, correct? So that becomes the angle for maximum area, correct? For maximum area. Is that clear to you? So indeed, a very interesting question. Well, in case you want to learn from me, you can always send an email on the address given. Feel free to write your comments and suggestions. They are always welcome. Thanks for your time and all the best.